Now it said to use the converse of the Pythagorean theorem to classify triangles. This was actually what I was going to look up a while ago because I'm trying to remember. I know if you got a squared plus b squared equals c squared, you definitely got a right triangle. Now, if I remember right, a squared plus b squared is greater than c squared. That's going to give me an acute triangle. A squared plus b squared, and y'all correct me please if I got these two backwards. And the reason I get them backwards is because the old curriculum I used wrote the expression backwards. So it tends to confuse my brain. It says triangle ABC has lengths of 5, 7, and 9 centimeters. Well, you know your hypotenuse, and I just assume it's a right triangle until I prove different. So your hypotenuse is always your longest side. So I just label it like that so I kind of know what's going on. So what I do is I set it up as 5 squared plus 7 squared. Now, I always put a question mark because I don't know that it's equal. So in your handy-dandy calculator, you just key in that 5 squared plus 7 squared. Now, I can't remember what it is. 25 plus 49. 74. That's what I wanted it to be, but I knew if I wrote it, it'd be wrong. And then 9 squared is 81. So now we know they don't equal, but the 74 is actually less than 81. So I'm going to say that this is an obtuse triangle. Now on this one, like I said, nobody corrected me, so I'm pretty sure I was right. But go back and check your LMS or your textbook and make sure that that's the way it works. All right. I like these kind of problems. These are puzzles, okay? Now, what you're going to need to know up there, it says using the Pythagorean theorem to find unknown in several steps. Well, let me tell you, you could use the Pythagorean theorem for this, but it's a lot easier to use for your first problem, a special right triangle. Now then, it tells you down here that this bottom is 1 centimeter, and if you look, they put tick marks everywhere. So I know that this side is also 1. I know this length up here is 1, and I know this length is 1. Well, if you look, these legs right here are congruent. So that means that this is a 45-45, 90 triangle. Also what you learned, of course I'm telling you, you always label your triangle before you do anything. You know that both legs equal x. And then you know that the hypotenuse is x root 2. So all I have to do is plug this 1 in for x right there. 1 times root 2 is just going to give me root 2. So what I'm going to do is I'm going to erase. So now I just know that side right there is going to be root 2. Oh, it's not going to let me move it together. How mean. There we go. All right, Fredeos, that's fine. This is recording. You can watch the rest if you need to. So now I know what the legs are of that middle triangle, and I got to find the hypotenuse over here. Well, so now this is where I'm going to use the Pythagorean theorem. My shorter side is 1, or leg. My longer leg is root 2, and I like to put parentheses around my roots before I square it. Well, Yeah, okay. I'm going to call this guy right here, I'm going to call him C. Okay, root 2 times root 2 is just going to give me 2. 2 plus 1 is going to give me 3. When I get the square root of both sides, I'm going to have root 3 equals C. So I know this right here is root 3. Now then, think about your 30, 60, 90 triangle, but think of it backwards. Okay? Usually you're told it's a 30, 60, 90 and you label it. This time it's already labeled, and we're going to determine which angle's which. Well, we know the side opposite is x. We know that this leg over here would be x root 3. And we know this right here would be 2x. Now then, the reason that I knew that this was going to be a 30, 60, 90 triangle is because that longer leg equals root 3. And if x is 1, if I substitute a 1 in for this x right here, 1 times root 3 is going to give me root 3. Okay? So that's how I knew that this was going to be a 30, 60, 90. And that just comes, just having that knowledge comes from studying. Okay? Because I've studied and studied and studied. So, now that I know that this is a 30, 60, 90 triangle, this would be 30 degrees down here, and this would be 60. Okay? If I plug a 1 in right here, I'm going to have 2 times 1 equals 2. Let me write a 1 there. So I know that in this problem, h is going to equal 2. Now then, had I not recognized the 45, 45, 90 and the 30, 60, 90, I could have used the Pythagorean theorem for every one of them, and I still would have gotten the same answer. Okay? So if you're not up to par on knowing your special right triangles, don't sweat it. For this one, you could have used the Pythagorean theorem for all 3 triangles. Okay, finding the area of sectors. It says find the value that most clearly represents the area of the shaded sector. Now, you've got to remember, a sector is just a portion of the whole circle. Okay? So earlier I said, oh, those are easy because all you're doing is setting up a proportion. The hard part is knowing how to set up the proportion. Okay? Once you've done that, it's just cross multiply and divide. Okay. So I've got, if you got the degree measure, that's really what you need to figure this out. So I'm going to have the degree measure over 360. 360 is always what you're going to put in the bottom, equals the sector, that's the area of the sector. Let me write area up there. Area of the sector over the area of the circle. That's always how you're going to set up your proportion. Okay? So the degree measure that they gave me for this sector was 60 over 360. I don't know the area of the sector, so I'm going to let that be x. And now, what about the area of the circle? Well, they told me over here that my radius equals 2. So to figure out the area of the circle, I'm just going to come up here right quick, and I'm going to calculate my area. Remember, your area of the circle is pi r squared. So I'm replacing the r with the 2. 2 squared is going to give me 4 pi, just like that. And then if I went ahead and multiply out the 4 pi, and then I'm just going to round it 2 decimal places because they didn't tell me to do any different. 4 pi is 12.57. Okay, so I'm going to come over here. I'm I'm going to put 12.57 down for the area of the circle. Now then, you can reduce 60 over 360, and that's pretty easy to do. Now, if you don't have a TI calculator, you might have to look up in your user manual to see how to do this, but I'm sure most calculators do it, unless it's a for function. But if I can 60 divided by 360, and watch this, if I push the math key, see number 1 says fraction, I'm going to hit enter, and then I'm going to hit enter again. So anytime you want to reduce a fraction to its lowest term, key it in the calculator and push math, enter, enter. Anyway, I got 1/6, so I'm going to come back to my problem. I've got 1/6, and I like to simplify it like this because the smaller your numbers are, the less likely you are to make a mistake. So I'm going to cross multiply 12.57 equals 6x. So I get, and I'm rounding it two decimal places, 2.09 equals x. And remember, x up here is the area of the sector. Area of the shaded sector was what I was supposed to find in my problem. So that's my answer right there. So like I said, once you got your proportions set up, this is pretty easy. But until you get to that point, it might be a little hard. Okay. Distance on a coordinate plane using the distance formula or Pythagorean theorem. I'm going to tell you, you should always use the Pythagorean theorem when you can. The distance formula, it's just got a lot of calculations in it, so that means there's a lot more room for mistakes. So the first thing that you're going to do is plot your points. So plot points. So I have a 5 and a -8. So there's that point right there. It's kind of off a little bit, but it's there. And then my second point is -3, 7. There we go. I'm going to come over here and I'm going to add a straight line, because if I tried to draw it, it would not be straight. Okay, my second step is, how do I want to word this? Create a right triangle. Create, that doesn't look like the word create, a right triangle. All right, well the way I do that is I come in, I'm making sure I'm on the right line. There we go. Ta-da! I created a right triangle right there. Now then, you look to see how many units tall it is and how wide it is. And once you do that, you'll see that all you got to do is use the Pythagorean theorem to figure out how long the distance is between those 2 points. So I'm going to come down here. I'm going to count my units. Well, you don't really have to count them because you know this is -3 and you know this is 5. So 5 plus 3 is going to give me 8 units. Up here, I know this is 7. I'm looking at my y values, and I know this is -8. 7 plus 8 is 15. So that's how long that vertical leg is. So my third step is the Pythagorean theorem. So you're going to have 8 squared. Oops, I almost put 7. And then I'm just going to use my calculator. I'm going to go ahead and say 8 squared plus 15 squared equals 289. And then I'm going to take the square root of 289. That's going to give me 17. Okay, now remember, I took the square root of both sides. So this distance from 5, -8 to -3, 7, is going to be 17 units. The area of a polygon given the perimeter. Now, I want you to pay special attention to how I work this out because this is for a hexagon. And on part 2 of your test, you have to explain why this formula works for a hexagon. Okay? So paying close attention to what I say and how I work this problem will help you answer that problem on the part 2 test. So it says the perimeter of a regular hexagon is 156 inches. What is the area? Okay, one thing you have to remember is when you have a regular, and let me emphasize the word regular, when you have a regular hexagon, and we're going to pretend this is regular, it doesn't look very regular to me. It looks kind of concave. It breaks itself up right there. You can draw 6 equilateral triangles. Regular hexagon has 6 equilateral triangles. That means all the sides have the same measure. Okay? And that's key to solving this kind of problem, is knowing that information right there. That's a very important property. Okay, so they've given me the perimeter. I'm going to write that up here. They tell me the perimeter is 156 inches. Okay, well, a hexagon has 6 sides. So I'm going to take 156 divided by 6. 156 divided by 6 gives me 26. So I know each one of these sides is 26. Okay, they want to know what is the area. Well, remember this A in our formula? Oops, that's not a very good arrow. That stands for apothem. Your apothem, let me change my pen color here for 1 second. Your apothem is that yellow dashed line right there. It always goes from the center perpendicular to a side. Okay? So I've got to go in and figure out what the measure of that apothem is so I can calculate the area. So what I'm going to do is I'm going to draw a larger equilateral triangle. I know that each side measures 26. Now, I'm going to have to use the Pythagorean theorem to figure out what that height is or what the length of the apothem is, because your apothem and your height are the same thing. In order to do that, I have to know the measure of this base. Well, all I have to do is divide that 26 by 2, and I know that base is 13. So now I can use the Pythagorean theorem to figure out what the height of that triangle is. Well, my A is going to be 13. I'm looking for B, which is the height. And then my hypotenuse is 26. So what I'm going to do in my calculator is say 26 squared minus 13 squared. That gives me 507. Now I'm going to get the square root of both sides. So I get B, which is my height. Let me put a B here so you'll know that's my height, is 22.52. Okay, so now I know my height, which in actuality is my apothem, so I probably should have used the letter A for my height. It would have been less confusing. So I'm going to put up here that my apothem equals 22.52. Now all I got to do is plug all my information into that formula, and I will know what the area of my hexagon is. So my area is going to be half my pothom is 22.52, and my perimeter is 156. All you got to do is plug all that into your calculator. You're going to say, I'm just going to put in one, I'm going to type in 0.5 for a half times 22.52 times 156. So for my area of my hexagon, I got this huge number, 1,756.56. That's going to be the answer. Okay, let me go over this with you right quick. Let's talk about why that formula works with the hexagon. Well, actually, it'll work with any regular polygon. Reflect back on the formula for the area of a triangle. I'm going to put A, T, or I could put just a little triangle, equals 1/2 base times the height. Okay, so you can see that the half matches, and then this A right here is actually the height of the triangle, and the B is the base, or actually if you come over here and look at this, it's the base of the triangle. Well, look at what we did. If you look in this hexagon, you've got 6 triangles. So if I know the perimeter, then I know the measure of the base of each one of those triangles. So your perimeter represents your base in the triangle formula. So then look, if you found the area of each triangle and add them together, you're going to have the area of the polygon, actually this hexagon. But let's say you had a pentagon, same thing. You got 5 triangles, you find the height, you find the area of each one, multiply it by 5, bam, you've got your pentagon area. It works for heptagon, octagon, all of them. So in actuality, the area for regular polygon is just a hybrid of the formula for the area of a triangle. Okay? But you've got to be able to explain why. So you might want to listen to me talk about this a few times before you try to explain it. Okay, finding the area of a composite figure. On these, you've just got to decipher the information they've given you and then start figuring it up. Okay? Now, when I first looked at this, I wanted to break it down a different way. But then I decided to go back and break it down like this. And it doesn't matter which way you do it, you're going to get the same answer. You're probably going to do about the same number of calculations. So I'm going to have to pause for just a second because my dog wants out. Hold on just a moment. On at the door and whining. Okay. So you see how I broke it down. So what I do now is I find out all my tick marks. I know that this bottom down here is 14 centimeters. Now here I've got these single tick marks. It says all 3 of those are congruent. So I know that if I were to add all 3 of those that I just marked red up, it's going to equal 18. So 18 divided by 3 is going to give me 6. which means these little portions right here also equal 6, which, by the way, 14 minus 6 is going to give me 8. So those pieces that I just wrote, or I added in there, are going to be 8. So now I've got 3 rectangles. All I got to do is calculate the area. 14 times 6, 84. So that means this is 84. 6 times 8 is 48. So I'm going to have 2 times 84 plus 48. So that gives me 216 centimeters for my area. So you just have to go through and figure out what is the easiest way to break that up into smaller portions that are going to be easy to calculate the area for. Now, when I said that you needed knowledge of the distance formula earlier, I put on here, read the lesson on the distance formula and take notes so you can answer questions involving and about the distance formula. They're going to ask you something about what other formulas the distance formula is similar to. You need to know that. That's just you reading and studying. It's not an example that I can show you. And then here's all the formulas, pretty much. The only ones that aren't on here I didn't think to put on were you need to know how to do the 30, 60, 90 for part 1 and part 2 of the test, as well as the 45, 45, 90. Because if they only give you the measure of one side and you have one of those kind of triangles, you won't be able to use the Pythagorean theorem. You will have to use these special formulas. And what I'm doing now is writing down what the measure of the sides opposite these angles are. So that's what you need to know. On that formula chart I sent you, you will see triangles with these labels. Okay? So it's not something you have to memorize. I've kind of already gone over this with you, so instead of going over it again and using up our time, if you go back to that area of the hexagon example that I showed you in part 1, it'll help you answer this question on part 2. And that's merely explaining why that formula works for finding the area of a regular polygon. Now, on this one, this is sort of like the question that is on the test. It's not the exact question, but what they're going to want you to do is tell them what the length of that blue dashed line is, and all they give you in the problem is the length of the prism. So one thing I didn't add on here, which you know that if you got a rectangular prism or a square prism or anything like that, you know you've got all the right angles right there. Something that I meant to add on here and didn't think was the 30, 60, 90, because we're not positive in every rectangle that's what the measures are. So if I wanted to figure out what the red dashed line, to figure out the blue dashed line, I have to know the red dashed line. So I really used a bad example here. No, I didn't. It's not that I used a bad example. I didn't fill in all the information we needed to know. No, I don't need to know that. Forget that. I did okay. Okay. Now then, no, let me erase this too because that's going to be in my way. Okay. Remember, the side opposite the 60-degree angle, you're always going to label x root 3. The side opposite the 30-degree angle is x, and your hypotenuse is always 2 times x. So, to figure out what that red dashed line is, I'm going to have to solve for x. So I know 12 equals x root 3. I divide both sides by root 3. And I have no idea what that is. Hold on, let me think. I'm not going to think. I'm going to use my calculator. How about that? I'm going to say 6.93. I'm just rounding it 2 decimal places. Okay, so now I know I'm going to cross this out. Oh, no, I'm not. I don't know what I'm doing. Oh, look at that. It just erased my lines. Awesome. So this, I'm going to replace that x with the 6.93. So I'm going to put times 2, 13.86. So I'm going to put 13.86 here. So now I know what the measure of the red dashed line is. Now this is what I forgot to put on there. You've got to know the height. So I'm just going to put that these guys are equal, which means that x equals 6.93. Okay, now I know all the information that I need to know to figure out that blue dashed line, because here I'm also dealing, I can't really draw it. Yeah, I can. That box right there goes from the yellow side down to the red dashed line. Okay, so let me draw that out here. This is what my triangle looks like now. I know this side is 6.93. I know this down here, I put 13.86. And I've got to figure out what the blue dashed line is. Now I just use the Pythagorean theorem. 6.93 squared plus 13.86 squared is, oops, well, okay, let me go ahead and write that out. 6.93 squared, trying to make sure I have enough room. 13.8 squared equals c squared, so that's going to be 240.12 equals c squared. So now I'm going to find the square root of that. So I get 15.50 equals c. So this blue dash line is going to be 15.56 inches. 0, not a 6. My 0 down there looked like a 6. Let me make sure it's a 0. So that's all you've got to do. I will tell you that the problem on the test is easier than this one. But it's the same process. Okay. The third one is kind of, for y'all, it's kind of confusing because whenever we've talked about proofs in the past, and I believe it's just 2 minutes after 12. This is the last example. If you want to stay in, if you've got to go, I understand. You can finish by watching the recording. Okay. The problem wants you to prove that this green triangle, the green figure is a parallelogram. And when you see the word prove or proof, you think you have to write a 2-column proof. But you don't in this one. They're just wanting you to use math to prove that it's a parallelogram. Now then, in order to do that, you've got to remember all the properties of a parallelogram, or have it marked in your book or in your notes so you can find it pretty easy. You're going to have to use the distance formula or the Pythagorean theorem on a coordinate plane, and as you know, I prefer to use the Pythagorean theorem. And you've got to know how slopes are related for parallel lines and perpendicular lines. because that's part of helping you prove whether it's a parallelogram or not. So, and notice how I wrote down here, prove WXYZ is a parallelogram. Something that I didn't add in the instructions right here that's very important to doing this proof is that write in alphabetical order, WXYZ are all midpoints, oops, left out the I, of quadrilateral ABCD. Okay? Now then, what you're going to have to do is calculate your distances. Okay? So you're going to look at your distance for XY, your distance for YZ, your distance for WZ, and your distance for XW. Okay. Now then, there again, you've got to remember what your properties of a parallelogram are. And when we were talking about, I think it was the very first example in part 1, I said one of the important things to remember, or some of the properties to remember, is that opposite sides are always parallel and they're always congruent. Okay? So in my mind, knowing those two properties, I'm not dealing with diagonals in this, so I could care less about those properties right now, about the diagonals of the parallelogram. What's important to me is knowing they're parallel, the sides, and knowing that they're congruent. Because if I can pick two sides and show they're congruent, then I know I'm on the right track to figuring out it's a parallelogram. So if I find the measure or the length of XY, I'm going to write down here, find the length of XY, YZ, ZW, and WX. Now then, this is where using the Pythagorean theorem or the distance formula comes in handy, because if you look, I'm dealing with these straight lines right here. Now, if they weren't straight, if they were slanted, then you'd probably have to figure out what their lengths were too, okay? So if I look from X to B, I got 1, 2, 3, 4, 5. So that's 5. And then here I got 1, 2, 3, 4, 5, 6. So I got 6 there. So 5 squared plus 6 squared is 61. Oh, no, I'm sorry. I shouldn't have put 61 right there. That's c squared. Or actually, in this problem, I'm not even going to put c squared. I'm going to put xy squared. Okay. So my 5 squared plus 6 squared equals 61. And now I'm going to get the square root of both sides. 61 is not a perfect square. How upsetting. I like perfect squares. They're pretty. So 7 point, I'm just going to go 2 decimal places, equals xy. So this right here is going to be 781. Well, if you look, this example that I've drawn, if you look, every one of these is going to be 7.81 because they all have the same leg measures. Now, the one on your test isn't going to be that easy, okay? Because if you go through and you count 1, 2, 3, 4, 5, 6, and then you count down here, you got 1, 2, 3, 4, 5. They're all going to work out that way. Okay. So I know I've got congruent, opposite sides are congruent. So that's telling me so far, yeah, I'm dealing with a parallelogram. Now, if I calculate their slopes and find out that they're the same, then I'll know that I'm dealing with the opposite sides being parallel. So I'm going to calculate slope for, I'm just going to say XY. I'm just picking a set of opposite sides, and WZ. So now calculating the slope here is pretty easy because I've already done some of the work. Look right here. You remember slope is rise over run. So if I want to find the slope from X to Y, right here, now it's going down, so I know it's negative. My rise is 6. My run is 5. So see, I've already done part of the work. So for XY, my slope is going to be negative rise over run. There we go. Now then for WZ, same thing. It's going sloping down from left to right, so I know it's negative. My rise is going to be 6. My run is going to be 5. So my slope for WZ is also negative 6/5. So since my slopes are the same, then those opposite sides are parallel. So I can come in here and I can put my little arrows that indicate parallel lines. Now I need to do that same thing for WX and ZY. So WX and ZY. Now if you look, they're going up from left to right, so that means they're positive. And then if you look, my rise here is 6, my run is 5. So for both of those, I'm just dealing with a positive 6/5. So I'm going to write out here the official way. WX is parallel to ZY. So there we go. So since the opposite sides are congruent and parallel, then I know I've got a parallelogram. I'm going to check right here and make sure that was the only thing. Yep, that was it. So your answer would be yes, WXYZ is a parallelogram. Now, if they wanted you to get more specific, we know that the sides are not perpendicular. Because remember, if they're perpendicular, you would have opposite reciprocals. So the opposite reciprocal of 6/5 would be a positive 5/6. So this is a rhombus. If they'd been perpendicular, it would have been a square. But since they're not perpendicular, I know that if they have congruent sides, then it's a rhombus. But your question on your test doesn't go into that much detail. They just want you to say whether it's a parallelogram or not. All right, well, that's going to be it for this review. I'm going to turn off the recording.